Hello, this is Clayton Balmas, and I'm your teacher here today in our audio classroom here at SynMax University at synmaxperformancelubricants.com. Today, we're going to be talking about a presentation. It's an OEM test on a 2010 V6 turbo, 450 horsepower, on a 160,000 mile endurance test. Now, the reason for this is it's going to illustrate coolant system results of fluid chemistry choice. And that was good or bad. See for yourself. I think you're going to like this one. Now, what we're going to have here is an OEM advanced design turbocharged 450 horsepower V6 engine. This was the factory results after 160,000 miles. Now, these pictures was from a factory presentation of an OEM test, endurance test, under extreme duty desert and mountain conditions. Now, I want to tell you that the coolant system was very, very well engineered. Now, the focus on this is that the coolant system and effects when you do not maintain a clean coolant regarding the mineral content and pH balance. You're not using advanced chemistries. Now, even though these test results might be original equipment acceptable, the minerals and coolant contamination still affects the heat transfer, acidic, and protection performance. Now, this is not an OEM design failure, but a coolant chemistry choice. Now, what we need to do is control contamination. Now, here's an advanced design, 2010, 450 horsepower turbocharged V6. And this is what happened when the factory really didn't focus on coolant system chemistry like they should have. Now, the effects of high mineral content contamination within the coolant fluid is evident within this presentation. Now, here we go. The mineral contamination within the engine block. You can see the rust spots on the aluminum engine. All right. Notice where the high mineral content or the contaminated water leaked through the intake area gaskets, and then it got trapped into the block. And then over time and heat, the water evaporated, and then the rusty minerals remained. Further, these rusty minerals got baked into and embedded onto the hot spots of the engine in the coolant system. Now, this would affect, over time, component durability. Now, this was the water pump. I thought this was really interesting, okay? You know, they did a fine job of coating the water pump and the block case and surface areas, but notice they didn't coat the shaft, all right? And what happened there is you can see some rusty water. You know, this rust in time will get into the bearings, and you will have a bearing failure. Again, notice that the pump shaft wasn't coated, and the oxidation will get into the pump bearings and seal and will cause a failure. Again, you can even see on this coated surface, here's some of the rusty water on the gasket edges. Now, here's the really important part that I'm looking at, and then we're going to get into it in a little bit. You see, obviously the factory didn't special coat the block passages, like the water pump. But notice that the rusty minerals embedded on or into the cylinder hot spot areas, which would be the upper piston on the exhaust side. This would affect the heat transfer. Here's the right cylinders on the exhaust side. Note, here's the left cylinder intake, on the left side, all right? Note the rusty minerals embedded into or onto the cylinder coolant passage in the hot spot areas on the upper piston and exhaust side. This does affect heat transfer and component durability. Again, you can see the hot spot minerals. Now, one of the things that you can see is that the rusty minerals in the coolant water stained and embedded upon the head gaskets. Here's the cylinder head side. Again, you'll notice the rusty mineral coolant leaking through the gasket areas. Okay? in the cylinder intake manifold front area. See, the minerals went through the gasket head. Here's another area on the bottom, excuse me. You're going to see the leakage here, all right, where the minerals went through on the head gasket in the center at the hottest point at the exhaust of the engine. Because what happens is, aluminum really does expand. So as the aluminum would expand, the minerals would get in a little bit, a little bit, a little bit. And then as it would expand again, those minerals would attach into the sprawls or the open metal pores at the smallest levels. And each time it would go by and flush out, it would take a piece of aluminum with it. I mean, that's basically what happens. And it eats and eats and eats and eats and eats until the point that, you're going to have water coming through and leakage at that point. Now again, you're going to notice the rusty minerals embedded in the upper piston exhaust sides. Now I will say, this is a wonderful coolant system passage that they have here. I am not saying that anything was designed improper on this engine. What I am saying is you see the effects of when somebody wasn't doing their homework on the coolant system chemistry. Again, here's the intake side, and you can see what's going on. Again, here's the other cylinders. You can see where it got into this, and it will affect the heat transfer capability. Now here's the answer. You see, these mineral contamination situations could have been prevented through an advanced coolant fluid chemistry along with a scheduled observation. Now, one of the answers could have been provided through the SynMax water cooler technology. Used with the recommended OEM antifreeze, it probably would have prevented these situations and increased component durability and heat transfer performance. Now, water cooler or a quality water science technology will increase performance in the following areas. It will double the performance of the ability of water alone, improve heat transfer and convection capability, reduce cylinder head and wall surface temperatures, reduce rust corrosion and prevent foaming, provide electrolysis and acidic with pH balance protection. It will help cleanse and lubricate the water pump seals, reduce cavitation, that means like, hot bubble little implosions, corrosion and foaming, reduce the scaling of coolant passages, reduce overall temperatures, which is very important in a turbocharged situation, and improve coolant system efficiency on an average of 5 to 10%. Overall, it would increase component performance and durability, and when the computer is sensing all this, it would allow more spark advance and increased power without having to spend one more dollar in engineering. Furthermore, it would allow all 6 of the cylinders, or help all 6 of the cylinders, to have a more efficient combustion chamber as it would run slightly cooler. Now, you say, well, Clayton, how do I know that this works? Well, we've got a radiator right here. Here's a fluidine radiator. I know this isn't 160,000 miles, but it has a theory. For 100,000 miles, you can see the coolant passages are almost like brand new. Now, that isn't rust that you see. That's actually part of the water chemistry that performed a coating, all right, upon the metal surface, which would reduce the static and increase the flow and also help with the heat transfer efficiency. You have another radiator that I'm sure if you would have cut apart the radiator that came from this vehicle the same way, you would see where the minerals got into the radiator, which greatly would have reduced the heat transfer efficiency as well. Furthermore, to simulate what is going on in the cylinders, you can see the hot spot, like say, for instance here on the oil cooler. You see where the hotter was on the right and cooler on the left. That is exactly what was also happening in the cylinder chamber. So we just don't start with those minerals and everything's fine. We want clean and efficient chemistry. Now here was another 72-hour test that was done. It was two chemistries. This was performed by an engineering firm in Detroit, and it was a 72-hour soak test. Here was the water cooler soaked for 72 hours. It looked like brand new with a cylinder sleeve. Here was a product used, I believe, in the Indy Racing League for at least the last 10 years, called Conklin. You can see how that had like a little coating on it. So here was the water cooler premix versus another chemistry. You can see how it was able to coat upon there, and it wouldn't rust. And then it also was good for, like, this here is the Teflon coating patch. So one of the resolutions for this is we've got our SynMax water cooler system treatment. This here is the concentrate, and inside you'll be able to have all the chemistries that you need. You need to mix this with purified water, or if you've got a 50/50 glycol in your antifreeze, that's great. Or if in your racing system, you got the good 7.0 water, you can mix it right straight in, and you'll have all the advanced scientific formulation additives that you need. Here we have the water cooler premix. It's a 1-gallon jug. It has the exact chemistry mixture with 7.0 purified water. Now the applications on this are very simple. You can use it 100% direct in your racing system. You also can use it for all weather. You can mix it a 1-to-1 ratio, 1 gallon of premix to 1 gallon of glycol for your all weather antifreeze needs. Use it in gasoline, diesel, or flex fuel. And furthermore, you can use it in your intercooler for your turbocharger or supercharger. So this is the end of our presentation, and now I again want to say that it had nothing to do with the design of the engine. The engine was designed beautifully. The coolant system was designed beautifully. It just showed the effects of when the coolant system has got too many minerals on it, attaching onto the surfaces. So that's all we're doing. And so this is Clayton Balmas here with SynMax University at synmaxperformancelubricants.com. I want to thank you for our time together, and I encourage you to look at our other presentations if you want to learn about the racing and commercial coolant system and chemistry performance efficiency. So thank you very much, and I look forward to seeing you at our next session. Bye now. For technical, test, and brochure information on how the Aerospace Advantage for Motorsports can work with your race team or other commercial requirements, please visit us at synmaxperformancelubricants.com.